Hello, this is Dr. Lam again, and this is the second tutorial video where I'm going to show you how to use Visual Studio Code on the JMU student server to work on 261 projects. Now this is, you should have watched the other video first, and you should have done the compilation lab and probably worked through the D level of Project Zero and skimmed the project guide. So there's a lot of things that you should probably do before watching this video. So I would recommend doing all those things. I'll put links to them below this video, but you should do all of that before watching this video. This is going to show you how to get Visual Studio Code set up to work with the projects in 261, but it kind of assumes that you sort of know how the project frameworks work in the course. All right, so the first thing we're going to do is I'm going to go ahead and just show you acquiring the project files. So I'm just going to SSH to Stu from PowerShell. You see that I don't currently have them anywhere. So presumably you will have already done all this because you've done the lab. So you will have a CS261 folder. And so we can go inside of it. And then we will copy the starter files from the specified location. So this is fall 2022. And so if you're watching this in a future year, you'll probably want to use a different path. But we're going to grab that distribution tarball and copy it into this folder here. And then we're going to extract it. And again, all of this was in the lab, so you should have done all of this already. And so once we go into that folder, we can see that everything is there, and we can build with make, and we can run with /intro. Okay, so now that we've seen that we've gotten all the files, let's go ahead and connect to Stu using Visual Studio Code. And I'm going to, remember there are a couple of different ways to do it. You can go here and then connect to host, or you can Control-Shift-P and start typing remote SSH and then connect to host. Either of those is fine. And then we're going to choose Stu, and it's going to connect. And I'm going to go ahead and close the local window here. All right, so we're now connected to Stu. So the next thing we want to do is open our project folder. So I clicked Open Folder, and then we're going to go into CS261, choose the P0 folder, and then go ahead and open that. Okay, so here are all of the files, and hopefully you've already made some changes to these files, and so this is probably an earlier version of the project than you're currently working with, but that's fine. So you'll notice that it has asked us if we want to install the recommended extensions for STI, and we do, so we want to click Install. And if you missed that, you can go search for these in the Extensions tab and go find them, but there's a C++ extension pack. Distributed by Microsoft. So we want to go ahead and install that. While we're at it, let's go ahead and install the Makefile extension as well. So we won't use this right away, but here in a minute we'll make use of this. So this is the Microsoft provided Makefile tools. So let's go ahead and install that as well. Okay, great. So now that we have those extensions installed, we can open up the file, and we notice immediately that we get syntax highlighting. We also will get IntelliSense. So if I start typing a function name, it'll start auto-correcting, and so I can press Enter. And as you can see, it will give us help text for some of these functions. So here we actually know the definition of is prime, and so it's giving us some pop-up help text. We could also right-click on the function name and go to definition, and it'll take us to the place in this file where it's defined. This works for type names as well, so later on we'll see that vector t is actually a new type that we've defined, and so we could go to the definition of that. And so hopefully having Visual Studio Code kind of helps reduce the amount of stress that might come from having a fairly large set of startup files to work with, because it'll help you navigate those files and move between them. And you notice that you can do that by clicking over here, but sometimes it's nice to be able to just click on something that you want to go see the definition of, and then let it go and find the location. You can also search for something using this. So if you had a particular string that you knew that you were looking for, a particular piece of text, you could directly search for it. So one thing that I really want to point out here is that all of the other resources that we've prepared for this course with respect to the projects are still valid. And if you press Control-tilde here, you can get a terminal window, and all of the other videos that have, exploration of the projects and the other tutorials that we have, everything here still works. So we can do everything that we used to be able to do from the command line, and we can do it right here. And so, we could actually even edit files in this, although we probably wouldn't want to do that here because we can edit the files using Visual Studio Code. But we can compile using make, we can run the programs using // and then the program name. We can even run them in GDB using GDB, so this allows us to kind of step through the program line by line and watch it run. So we can still do all of that. And I want to encourage you to learn how to do all of those things from the terminal. But for now, I'm going to show you some shortcuts that let you use the graphical interface to do these things. So the first thing we're going to do is set up the Makefile extension. So if you click on the little Makefile button here, you'll see that it lets you pick a couple different targets, and the only one that we care about is the build target. So you'll remember from the command line lab that the Makefile here, so exit out of that. So the Makefile specifies how to build the project. And this one is a little bit more complicated than the one that you used in the Makefile lab, but the general idea is that default specifies that we're going to build this executable, and then later on we show how to build that executable by invoking the C compiler. So let's go ahead and tell Visual Studio Code that the main build target is going to be that default target up here. And that's the first one that's listed in the file. These are just some variables. And so that's what's built by default when we press make or when we type in make. And so we want that to be the default when we press build in the interface, which is this button right up here. So clicking this button on the Makefile tab is essentially the same thing as running make from the command line. And you see that it rebuilt the main module, which I had edited, and then recompiled the final executable. So every time you make a change, you're going to need to either run make from the terminal or come over to this Makefile window and click the build current target button. Okay, so now let's look at running and debugging in VS Code. And in order to do that, we need to create a launch.json file. So they have a little link here that builds a shell one for us. It's empty at this point. And so we need to set it up. So put your cursor right in between those two square brackets and press enter. And then we're going to use curly brackets to start a new configuration. And then I'm looking off to my notes off to the side here. I wouldn't expect you to know all of these directly, but you can just type them in. So we're going to give it a name, and we're going to give it the default name, so just launch. We are going to set its type, and it's going to be CPPDBG for C++ debug. That's good. And then we are going to set the request to launch. We are going to set the program, and we'll accept the default here, except that the name of the program isn't a.out, it's intro. You may remember a.out from the command line lab. There are no arguments for now, so we'll just leave this empty, but once we start having arguments, so for instance the -G for the goodbye mode, the arguments would go here, and if we had more than one of them, we would specify them by separating them with commas. But for now, we're not going to pass in any parameters, so we'll just leave that empty. And then we need to set our working directory, and we'll accept the default there. So that was a lot, and none of it is particularly important to understand. It's just options that the that Visual Studio Code needs in order to invoke the debugger. Really, the most important thing is just understanding that later on when we need to add command line arguments, we can put them in here. All right, so let's go ahead and save this. So I pressed S, and you'll notice that it now detects that we have a launch configuration here. Now, this program doesn't do too much at the moment, so I'm just going to add a short loop here. So we're going to take I from 0 up to 5, I++, so this is just going to print a couple of things. So we'll print loop and then the number. Okay, so this is just a simple loop that is just going to print out loop x, where x is going to be 0 up through 4. So let's go ahead and save and recompile. So we go to make and then build, or alternatively, on the terminal, we could have just type make. And you'll notice that I made a typo here. I said print instead of printf, and it is conveniently telling me that I did that. So I'm going to go ahead and fix that and recompile. All right, so now we have successfully compiled, and so we can now go over to our run and debug. But before we do that, I'm going to set what's called a breakpoint, because otherwise it's just going to run the program and not stop anywhere. So I'm going to set a breakpoint here at the beginning of main, and I do that just by clicking out in the margin here, so you can turn breakpoints off. And you'll notice that it appears down here, showing that it's going to pause execution at line 11 of main.c. So at this point, now we can click the little green triangle here, and it will start the debugger, and it takes a little while to get going. And then once it pauses, we now have a lot of information about where the program is running and what it's doing. I recommend switching back over to the terminal at this point so that you can watch the output of the program. So the current line is highlighted here, so we've got this little yellow arrow here, and it's highlighting this line. So I'm going to go one step further, one line of code further, so that we can see this output and we can see that the state of the execution has changed so that we have finished this printf. So I'm going to click step over, and that's going to move execution down here. So we're now on this next line. We've gotten our hello CS261. That came from this line here. And you'll notice that now that we're inside the loop, we have a local variable called I, and it's initialized to 1. And so, we can kind of, go through the loop a couple of times, and we'll notice that we're getting output down here. I is changing up here. And so another nice thing that Visual Studio Code does is that you can actually just sort of hover over different variables in the code, and it will tell you what the current value of that variable is. Here's the call stack. So if we had other functions running, you'd be able to see them there. If we are particularly interested in one of these values as it changes, we could add it to watch so that it always appears over here. And one other really nice feature is a hardware watch point. I cover this in my tutorial, my debugging tutorial, but in Visual Studio Code, it's called break on value change. So if we had a particular value and we suspect that it's changing at some point where it's not supposed to be changing, we can take that variable and we can say break on value change. And so now we have a breakpoint that is going to pause execution at the next point that I changes. So rather than stepping, I'm now going to continue the program, and it's going to run until the next time that I changes, which here is just I changing from 1 to 2. And you see that the change is highlighted here. So obviously this is not terribly complicated, but once you start working with raw memory pointers, this is a way to help find some subtle memory bugs where things are changing and you're not quite sure where they're changing. Okay, so I'm going to go ahead and stop the debugging here. There's so much more that you could say about debugging, and I do have some tutorials on debugging. But I would encourage you to explore and play with this and look for other tutorials online. There's a lot of useful things here that will make your life easier as you work on the projects in this course. But I don't want to spend too much time covering them all right now. All right, so the last thing that I want to cover here is just a very brief introduction to using version control and Git. And so you may be aware that you can use a website called GitHub to store your code. We're not going to do that, though. We're just going to use Git locally on Stu to keep track of old versions of code so that you won't risk losing anything. And that's why I recommend doing this, because it's really easy when you're new to all of this to accidentally overwrite your files. And this ensures that if you do that, you'll be able to recover your old work. So in order to get this set up as a Git repository, all you need to do is go to the terminal and type in git, G-I-T, space init for initialize. And so this creates an empty Git repository, and you'll notice that it now is displaying a number here in the source control tab. So it's detecting that there's a whole bunch of files here, and they're mostly in the tests subdirectory. So they're mostly things that we don't particularly care about. It's also listing the .o files and the intro file, and those are compiled binaries. So the next thing that I want to do is show you how to create a git ignore file. So we're going to create a new file. We're going to call it git ignore with a dot in front. So this is a hidden file. It won't show up in our ls by default, but this is just the special file name that it has to have. So .git ignore, so make sure you spell that right. And then inside that file, we're going to list things that we want Git to not worry about. So we don't want the intro program to be stored in our version control. We don't want any of the .o files to be stored in our version control file. There are log files that are generated by VS Code. We don't want those. And for now, we won't add anything from the tests directory. You might want to change this later if you start adding your own test cases. But for now, we just kind of want to ignore all of the test folder so that we don't store that in our version control, because we can always get that back from a fresh checkout if we need it. Okay, so I'm going to store that, and you'll notice that makes the number here go way down. So now there are only these files that we're going to be adding to our version control. And that's great. So let's go ahead and do that. So go ahead and select all of it. So I just clicked up here and then held down Shift and clicked down here. And so I'm going to stage changes. So Git is fairly complex, but there is kind of this two-stage process for saving your changes. So you have to stage them. And once you staged them, you put in a commit message up here. So this is the initial commit. And then we'll commit. And the first time you do this, you'll need to configure your identity. And you'll notice that it's showing you the line here, the lines that we need to run in order to set this configuration. So we're going to copy that line, go back to the terminal, right-click to paste, and then we'll just put in your own email. Actually, I'll just leave that. So you'll put your own Duke's address here, and then go back and copy this, go back to terminal, paste it in, and again, you're going to want your name here, so I'll just go ahead and put my name in here. So I'm Dr. Lamb. Okay, and so once we've done that, now we can commit. And we won't need to do that again. That's a one-time setup thing. And so now we can see that there are no changes. And so from here on out, it's going to track all the changes that we make individually. So let's say that I added a new line here that prints goodbye. This is sort of like what you need to do for P0, but a little bit different. And so I'll save the change. And you'll notice that change now appears here under the version control tab. And if I click on that change, I can see exactly what that change was. And so this allows me to kind of keep track of what I have changed, what I've edited since the last time that I committed my code. And so I could work on this for a while, and then once I have reached a good stopping point and I want to save where I am, I'll come over here and find all the changes that I want to keep. I will go ahead and stage the changes, and then add a little message up here that describes what I did. So I said here, I add goodbye message, and then commit. And so now those changes are saved, and if I ever need to get back to that, I can. All right. Again, there's a lot more that could be said about Git, and I highly recommend going and finding some tutorials or coming to a GMU Unix users group meeting about all of this. There's a lot more that could be said, but should be good enough to get you started. I hope that, again, like I've said before in this course, I hope that you try to cultivate a sense of control over your work environment. If you're unsure what something does, try it, or read up on it and read some documentation and figure out what it does, because there's a lot of tools here, and it's a lot of things that are going to make your life a lot easier as you work on the project. And as always, feel free to come to office hours if you have questions, or like I said, the Unix users group is another great source of help for all things command line and Linux. All right, good luck.